Very good morning to my fellow student. So, how are you today? So, hope you are good. All of you are good now. So, today we'll start with the continue to the topic of sound wave, and the subtopics for today is sound wave 2. Ladies and gentlemen, the aim of study today is to study the propagation of the sound wave and the formation of the standing wave. Lesson objective. In this lesson, students understand the formation of stationary wave in a crosspipe, understand the formation of stationary wave in an open pipe, understand the formation of standing wave in a vibrating membrane, and understand the formula for the frequency of sound wave produced in both open and the cross pipe. Okay, ladies and gentlemen, now we are going to the another lesson. Okay, go to the slide of the lesson. So now we go to the slide now. So introduction. When the musician blow into the mouthpipe of the clarinet, it causes thin wooden reed to vibrate. The vibration is transferred to the A inside the clarinet. So this results a stationary longitudinal wave being formed inside the clarinet. So next, we click on the clarinet. We notice that the sound is produced when blow and press. So next, when the musician blow across the mouthpipe of the flute, it causes a vibration in the A inside the flute. So this results in a stationary longitudinal sound wave being formed inside the flute. So we notice a very nice sounds, right? So how about the sound wave produced by the drums? So sound is produced by stationary wave, set up in a vibrating membrane such as in drum. So that are the sound produced. So today's lesson, as what we discussed just now, so you were able to understand the formation of the stationary wave in the cross pipe, in open pipe, in the vibrating membrane, and understand the formula for the frequency. Okay, next. Next, we notice that let's say for the instrument, which are one end open and one end cross. Okay, when the sound is produced, the wave similarly like start at the 0 point at the end, and the other end is open. Once the other end is open, seems that the wave vibrate with the maximum amplitude at the open end. Means that that is the empty not at the open end. For example, the fundamental mode is like that. Meanwhile, there will be the one open end. If the first overtone, there will be another open end. And also the second overtone. No matter how, sorry, no matter how at the end of the open end, they always with the anti-knot. Just the difference is the frequency. Okay, for fundamental knot, okay, the frequency is the lowest, and the first overtone, the frequency, fundamental, the frequency is the lowest. First overtone, the frequency is higher, and second overtone, the frequency is higher than the first overtone. Okay, now we go to the vibration. We notice that there are some, okay, some particle where this particle is not in the knot condition, and this one in the knot condition. We notice that they are vibrating or not vibrating, but almost vibrating with almost zero frequency, zero amplitude. Okay, where at the point with the maximum amplitude that means that it's an anti-knot. We notice that, okay, we notice that the two particle, let's say on very near to the, okay, near to the anti-knot, we notice that, okay, or even the anti-knot. So that means that they will vibrate with greater amplitude, greatest amplitude or greatest distance. Okay, this is for the, okay, second overtone. Next lesson, next slide, sorry. For the fundamental knot, okay, fundamental knot, how many number of knot we have? We have one knot and one number of anti-knot. For the first overtone, how many number of knot? Okay, first overtone we have two knot and we have two anti-knot. For the second overtone, we have three knot and three anti-knot. All this we must remember according to the, okay, let's say the first as the second overtone we have one knot, two knot, and three knot. How many anti-knot we have? One anti-knot, two anti-knot, and three anti-knot. For first overtone, one knot, two knot, and one anti-knot, two anti-knot. For fundamental, we have one knot, one anti-knot only. Next, we notice that if the sound wave produced is in the fundamental knot, that means while we adjust, we notice that, okay, this will be the distance. Distance of L means that length of the instrument. The stationary produce the fundamental sound. Stationary wave produce is just 1/4 of the lambda. That means that one complete oscillation or one wavelength, one lambda will be equal to 4L. Okay, for the next sound wave, where we notice that now is in the first overtone. First overtone means that this will be the L, the relationship between L and the lambda. That means that L is equal to 3/4 lambda. Or we said that the lambda is equal to 3 lambda is equal to, okay, 4 over 3. For the next, we notice that there is the second overtone. Second overtone means that this will be the wavelength. And the L, okay, the relationship of the L, okay, the lambda is shorter than the L of the distance of the instrument. Then what we need to say that for the fundamental, okay, for the fundamental mode, when the particle vibrates, that means that the distance of vibration, maximum distance of vibration, okay, so we said that is the, okay, the distance of correction, that will be a C. So meanwhile, okay, for every vibrating system, they need to be consider the L. That's why L plus C is equal to lambda over 4. L plus C equal to 3 lambda 1 over 4. But L plus C 5 lambda square, sorry, lambda 2 over 4. So from here, okay, generally, once if the question they didn't ask us to consider the C, if the question, I repeat again, if the question didn't ask us to consider the C, so we just assume that L plus L equal to lambda over 4 for the fundamental mode. For the first overtone, is L equal to 3 lambda 1 over 4, and the second overtone is L equal to 5 lambda 2 over 4. If condition, if the question didn't ask us about, do not ask us consider about the C. So we just ignore the C, assume that there is no C, because the C, actually the distance is very, 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 very short and small. Okay, next. From here, fundamental mode. Okay, ladies and students, ladies and gentlemen, we need to rearrange the information given, where the information here given are mixed. So that means fundamental mode, okay, should be the fundamental frequency is F0. Okay, where the first overtone will be the F1 is equal to 2F and 3F. So from here, we notice that wavelength, okay, for the fundamental mode, the wavelength is the, okay, how is the wavelength? Just now, okay, it should be, okay, this is the fundamental mode. First overtone and second overtone. So from here, we can notice that how many knot, how many anti-knot? One knot, one anti-knot, one knot. Okay, and two anti-knot, two knot, last three anti-knot and three knot. Okay, so meanwhile, the frequency, okay, this wavelength will be the 4L. Okay, 4 times of the length will become one wavelength. Okay, and second one will be 4 over 3L. And last, for the second overtone will be 4 over 5L. So this means that we can notice that as we know that V is equal to F lambda. Frequency is inversely frequency, okay, frequency is equal to V over lambda. So from here, as we know that lambda is equal to 4L, so that means over frequency over 4. So that means that this will be the fundamental frequency. So the shorter, because it's inversely proportional, the shorter the frequency, sorry, the shorter the wavelength, the shorter the wave, sorry, let me see that. Okay, once we convert to, okay, we cannot use the, after we convert to the frequency, where B equal to F lambda, okay, we notice that the frequency for the fundamental not considered is the 4F prime. And the first overtone, F1, the frequency of the first overtone will be equal to the double of the fundamental mode. And F2 is the second overtone will be 3F0. And if F3 equal to 4F0, okay, and F5 equal to 5F0, and so on. Okay, so as a summary, a cross pipe is closed at one end and open at another. And we know, okay, this is a cross pipe. And for the stationary waveform in a cross pipe, knot is formed at the cross end. For the fundamental mode of vibrating, the wavelength of the stationary wave is 4 times for the length of the pipe. The fundamental frequency F0 equal to V over 4L, where V is the speed of the sound in A and L is the length of the pipe. If C is the end correction, okay, that's it. If we consider the C, L plus C equal to lambda over 4 for the fundamental knot. For the first overtone, L plus C equal to 3 prime 1, 3 lambda 1 over 4. For the second overtone, L plus C equal to 5 lambda 2 over 4. If the end correction is not considered, so the fundamental knot mod L equal to lambda or lambda knot over 4. For the first overtone, L equal to 3 lambda 1 over 4. And for the second overtone, L equal to 5 lambda 2 over 4. Ladies and gentlemen, so we notice that for the, okay, for the sound wave produced, okay, just now we noticed that is the one closed end, one open end. Now consider the stationary wave produced by both open end. Okay, so we consider this is open end pipe. So same thing, the fundamental mode produced, and the first overtone sound will be, and second overtone, we notice that the frequency of the vibration is higher and higher. But no matter how, at the end, they still have the, okay, open. They still have the, at the both open end, they still have the anti-knot. Ladies and gentlemen, we notice that for the fundamental knot, how many knot and how many anti-knot produced? One knot with 2 anti-knot. So this means that there will be one knot and 2 anti-knot. Okay. For the first overtone, will be one knot, 2 knot, and 1 anti-knot. Sorry. 1 knot, 2 knot, 1 anti-knot, 2 anti-knot, and 3 anti-knot. So this means it will be 2 knot and 3 anti-knot. For the second overturn, we will have 1 knot, 2 knot, 3 knot, 3 knot with 1, 2, 3, 4 anti-knot. We have 3 knot and 4 anti-knot. Ladies and gentlemen, the number of knot and number of anti-knot are various in the open pipe. Cross pipe, one number of knot, one number of anti-knot. They are same. Okay, so this means that there are the difference between the cross pipe and the number of knot and number of anti-knot for the cross pipe and cross pipe and open pipe. Sorry. Okay, next. For both open and pipe. For fundamental knot, we notice that the length will be half wavelength. This means the L is equal to half of the lambda, or we notice that lambda is equal to 2L, double of the length. For the first overtone, the sound wave, okay, the sound wave similarly, okay, exactly L equal to lambda. Okay, the L is same as the wavelength. And next, we notice that for the second overtone will be how much? So we notice that this is the L, this is the lambda. Okay, so this means that this will be, okay, 1, 2, 3, 4, 5, 6. Okay, 6 over how much? 6 over 4 lambda. Okay, so 6 over 4, this means that 3 over 2 lambda, 1.5 lambda. Okay, so lambda, okay, sorry, lambda wavelength, this is a wavelength. Okay, and this blue line will be the, okay, the stationary wave in the. So now, same thing, if both ended, if the end correction are considered, the end correction will be 2C because both ends are open and the particle at the both ends are vibrate. So L plus 2C equal to lambda over 2 for the fundamental. First overtone L plus 2C over lambda 1. For the second overtone L plus 2C equal to 3 over 2 lambda squared. If the question do not consider the C, this means that L equal to lambda over 2. L equal to lambda 1 for the first overtone and L equal to 3 over 2 lambda 2. So for the second overtone, okay, if the question didn't ask about the end correction. Ladies and gentlemen, again, for the fundamental mode, the diagram will be like that. First overtone and second overtone. For the fundamental knot, we have 1 knot, 2 anti-knot, 1 knot, 2 anti-knot. And for the first overtone, okay, we have 3 anti-knot and 2 knot. Second overturn with 4 anti-knot and 3 knot. For the wavelength, for the wavelength, this will be 1, 2, that means half of the wavelength. Okay, so L is equal to half of the wavelength is equal to 2L. This for the first overturn, lambda equal to L, and second overturn, lambda equal to 2 over 3L. Against fundamental frequency is F0. Then what we find that, okay, the F1 is equal to 3F0 and F2 equal to 5F0 for the second overturn. As a summary for the open pipe, an open pipe is open at the both ends. For the stationary waveform inside an open pipe, anti-knot are formed at the open ends. For the fundamental mode of vibration, the wavelength of the stationary wave is 2 times the length of the pipe, and the fundamental frequency F0 equal to V over 2L, where V is the speed of the sound in air and L is the length of the pipe. If C is the end of correction, for the fundamental mode, L plus 2C equal to lambda naught over 2. For the first overturn, L plus 2C equal to lambda 1. For the second overturn, L plus 2C equal to 3 over 2 lambda 2. If the C is not considered at the end, this means that I cannot consider the end correction, L equal to lambda naught over 2. First overturn, L equal to lambda 1. For the second overturn, L equal to 3 over 2 lambda 2. Next, for membrane drum. For the membrane drum, okay, if we hit to the drum with one stick only, that means the vibration is at the center. If we hit at the both end, this will be like that. Okay, so in this lesson, okay, for the drums, we do not have much okay calculation or not have any calculation in the membrane drum. Sorry. In this lesson, we just consider to the open pipe and the closed pipe only. One and one open or both open pipe. Okay. So for the drum, summary for drum, two-dimension vibration can be set up in the flexible membrane stretched over the circular hoop such as the drum. Anti-knot is formed at the point where the membrane is struck, and knots are formed at the perimeter. The resulting sound produced by the membrane is explosive in nature. Explosive in nature, that means, okay, like the explosion. The vibrating membrane creates a sound of indefinite pitch. This means that the sound is very loud. Okay, ladies and gentlemen, these are the lessons for today. Okay, so this will be the question for the lesson today. Okay, so we have question 1, question 2, question 3, question 4, question 5,
question 6 and question 7.
So this is the exercise for today.
And the answer for question 1. Answer for question 2. Answer for question 3. Answer for question 4. Answer for question 5. Answer for question number 6. Answer for question number 7. That's all for today's lesson. Thank you very much and